Greetings everyone. In this video, I'll be showing how to use Apache Spark to load, process, store, and visualize a streaming dataset using Spark structured streaming. First, let's take a look at the work plan. We'll be writing 4 Python programs, one of which will have to be using Jupyter Notebook to do the coding. Now I'll do a quick demo on how the final outcome of the programs that we'll be writing and see how it will come out like. Basically, I have laid out the screen to run the different program and also a browser to actually do the visualization chart display. Okay, showtime. First window, I'm actually running the generate transaction program, which actually generate the customer order, and as you can see, it starts streaming in. At the same time, it will also create a lot of transactions of this customer order into transaction files into a certain directory, which I'll be monitoring. The second program is going to read the stream of log files that's been generated in the first program and process it and insert the count of the transactions into a database table called customer aggregate transactions. The third window is just a PowerShell command window, and I basically run a directory command to see what the log files that's generated in the folder that the output will be stored to. Bottom left is actually a program that reads the transaction table called the customer aggregate transactions on a regular 6-second basis to let me know that how many transactions has been recorded into the table so far. At the browser on the top right, that's where the visualization chart for the transaction count will be displayed, but it's actually the Jupyter Notebook that would be running the program that is on the second window as well. When you first start up the browser and load the app page, basically you do get a bit of error if the data hasn't started coming in from the Spark streaming program that's processing the data. You can just ignore the data, it will clear after the record started coming in, and you should see the visualization chart come up pretty nicely. For the app that is presenting the chart is running, I can still continue to modify it, and that's because the app is running in debug mode. So if I start to change the code that changes the color of the app, it will start to re-update and refresh itself, and you will start to see some error, but subsequently you see the color changes to the one I have made the changes in the program for. Before I set forth to write the first program to simulate the transactions of the customer orders streaming in, I had to set up a database, and basically it's sort of like a customer orders database with customers, product orders, and order details. But additionally, there's a customer aggregate transaction which will be used to log the transactions count of the customer orders coming in. Let's go to the first program that I wrote to generate the customer order to simulate the stream of customer orders coming into the environment. So in the Python program, the first thing I did is to figure out how many customers and products there are, which are used as the maximum number for generating the random number for the customer ID as well as products. I built in the scenario for multi-order lines per customer, but I kept it to a max of 2 lines. So you insert into the order header and then create the order lines, 1 or 2 lines depending on the random number generated, and then up to a maximum of 6 quantity of a product in each order line. So in addition to logging the product and the transaction count into log files, this is actually simulated creating the order into a customer sales order database. Next is this program that is written in Jupyter Notebook that will read the stream of the product transaction count, and then those are actually read from the log files in the folder and process them and save the processed data into the database table. So the program will actually read the log file that's been generated into the baked-in transactions folder, and then read it in as a stream of files and process the counts in a window of 60 seconds, and thereafter insert it into the customer aggregate transaction database. The third program I have is something I call optional, because basically it just look at the table customer aggregate transaction and display the count of the records inside there. It's nice to have, and basically it actually regularly look at the table every 6 seconds to display the count, so I know that the count is increasing. So in the program, nothing fancy, just connect to the MySQL database, and as I said, every 6 seconds it will just do a query and display the count of the records in there. Lastly, most interestingly, this is the Python program that is actually a dash app that actually reads the transaction count from the database table, customer aggregate transaction, and present the visualization chart on a live basis. So the program uses the dash library, and basically in the beginning I just do some formatting of the layout, and there's a callback that will actually regularly refresh the chart, and it connects to the database and reads the customer aggregate transaction, group them by a time window, and present the count in the chart as a bar chart. There's this part with different colors there I've been experimenting with, and basically I actually use it to play the colors, and when I update it, it actually does a refresh of the app, and the bar chart will actually changes different colors. And the reason you can have the color changes is because we're running the app server in the debug mode, so you will actually refresh when the code is changed at the back end. And that's how the 4 programs are according to the work plan we have in the beginning. Technically, you do not need the optional program to handle the charge. In my case, after running about half an hour when I open the browser to a full screen mode, I can see the chart having filled to almost the whole breadth of the chart, and it will continue to stream the data in. So I hover over the bar, I can see the count for each of the 1 minute window. At the top right hand corner of the chart display, you can actually see some of the icons which allows you to do different functions to the bar chart, like zooming in and out and panning and scrolling to the different parts of the time. Lastly, I'd like to take a look at the transaction that has been ingested or created at the simulation exercise after about an hour or so. So basically, in the beginning, the customers and the products are all there, but after about half an hour later, there's 852 orders and 1,000 over order lines, and basically more than 300 transaction counts. And that's how we can apply Apache Spark structured streaming to process streaming data to build some chart that is presenting the visualization on a live basis. Thanks everybody for watching. I hope you find this useful.